Alrighty, the final section, 2.8, is graphing two variable inequalities. So graphing linear inequalities, you're going to be graphing them very, very similar to just graphing a linear equation. The only difference is now there's going to be an inequality sign. So we need to think about dotted or solid lines and then shading. But we're going to graph this just like it was y equals 3x minus 1. That this 3 is my slope, this negative 1 is my y-intercept. So I'm going to go down to negative 1, plot my y-intercept, and then my slope is 3. So up 3 over 1, up 3 over 1. Or I could go down 3, back 1. And then from here, I'm going to look at my inequality. It's greater than. Okay, and I kind of made this chart over here on the right, that if it is greater than or less than, it's a dotted line. If it's greater than or equal to, less than or equal to, it has this line underneath of it, then I'm going to make a solid line. And then if it's the less than sign, I shade below. If it's greater than sign, I shade above. Okay, so this one is greater than. It doesn't have the line underneath of it, so I need the dotted line. So I make my dotted line through. And then it's greater than, so anytime it's greater than, then I'm going to shade above it. And so think of this y-intercept as negative 1. All my y-intercepts that are greater than above it, so I shade right here. This next one, I have y is less than or equal to negative 2x plus 1. So my y-intercept is 1. My slope is negative 2 over 1, so down 2 over 1. Down 2 over 1, or I could go up 2, back 1. It's less than or equal to, so I need a solid line. And then since it's less than that, think of my y-intercept as 1. The numbers get less than down here, so I shade everything below it. Now, if you're having a hard time deciding which side to shade, just pick a point on one side or the other side of the line. Don't pick a point on the line. So, for example, if I pick 0, 0, which is below my line, and I plug that into my equation, I want to see is that a solution or not. So my y would be 0 is less than or equal to negative 2 times my x is 0 plus 1. 0 is less than or equal to 0 times negative 2 is 0 plus 1 is 1. So 0 plus 1 is 1. 0 is less than or equal to 1. It's eating the bigger number, so 0, 0 is true. It's a solution. So 0, 0 is down here. So all of these would be solutions. Now, if I would have picked a point up here, it would have made it a false statement, so I would have known to shade the opposite side. Now, this third example, notice how the y is not by itself, so that's my first step. I want to get the y by itself. So this 1 is positive, so I subtract 1 on both sides. So that negative 1 just goes on the end. I can't put it inside my absolute value bars. And then it's negative y, so I can put a 1 here. That makes it easier. I need to get that y by itself, so I'm going to, they're multiplying, so I'm going to divide by both sides by negative 1. Those cancel out. And then I'm dividing by a negative, so I need to switch the direction of the inequality. Anytime that we multiply or divide by a negative, I have to switch the direction of my inequality. And then think of the number out in the a slot as just 1. So 1 divided by negative 1 is negative 1. And then that absolute value bars, that stays the same. The negative 1 divided by negative 1 is just plus 1. So this is my new equation. I'm going to now graph it. So this plus 2 means it goes to the left 2. This plus 1 means it goes up 1. And then this negative 1 is my slope. So it goes down 1 over 1. Down 1 over 1. Or I reflect that over because it's absolute value bar, so it's going to be a V shape. It's not just going to be a line. So I have this V shape going. It's greater than it. There's no bar, so it has a dotted line. And then it's greater than, so I shade everything above it. Those would all be solutions. Number 4, again, I need to get my y by itself. So I add 4, add 4. These 4's cancel out, so I get y is greater than or equal to 2 times the absolute value of x minus 1 plus 4. And then from here, this minus 1 means it goes to the right 1. The plus 4 means it goes up 4. 1, 2. And then my slope is 2. So make that a fraction. Up 2 over 1. Up 2, back 1. Up 2 over 1. Up 2, back 1. I get that V shape, which it should be a V shape because of those bars, and then it's greater than or equal to, so I need a solid line, and then it's greater than, so I'm shading everything above. If it was less than, I shade everything below it. This next one, I'm giving you the graph and I want the equation. So for this one, notice how I moved it to the right 1, 2, 3 units. So to move it to the right 3 units, I need to do the opposite. So I'm going to subtract 3, moves it to the right 3. And then I moved it down 2 units. So I subtract 2 at the end to move it down 2 units. And then it's dotted, so I know I'm not going to have a bar underneath my inequality. And then I shaded above, so it's going to be just the greater than one. So that would be my final answer. Let's try one more of these, but I'm giving you the graph, and I want the inequality. So for this one, I moved it to the right, or to the left, sorry. 1, 2, 3, 4 units. So I moved it to the left 4, and then I moved it up 3 units. So to move it to the left 4, I'm going to add 4, do the opposite, and then I moved it up 3, so I'm going to add 3. And then notice this one, the slope is going down 1 over 1, down 1 over 1. So my slope is -1. So I put that negative out in front, or you can just put a -1 either way. And then it's shading above it and it's a dotted line, so it's just going to be the greater than symbol. If it was a solid line, I would need that bar underneath of it. So then that is my final answer, that it is y is greater than -1, or just negative, times the absolute value of x plus 4 plus 3.